We're going to be looking at compound interest. We're going to be using this formula. So what it says is the amount we're going to have at the end is the product of the principal, basically how much money we start with, how much money gets invested, times 1 plus the rate over the times that it gets compounded, and then to the powered nt. All right, let's take a look at this as an example. Now, I have the formula there on the right. There's the formula. How much money will there be in an account at the end of 5 years? So the T is 5 because it's 5 years. If 1,000 is deposited, so the principal money we start with is 1,000 at 3%. So the rate, when I write it as a decimal, is 0.03 compounded quarterly. So my n is 4 because it gets compounded 4 times a year. Assume no withdrawals are made. So I'm just going to use my formula. Remember, A is how much money there will be. So using the formula, I have 1,000 times 1 plus 0.03 over 4. Now, n times t, I know how much n is. I know how much t is. So I'm saying this is to the 20th power. I'm going to work that out. Now, if you have a calculator where you can type all this in, well, just type it in and you're good to go. Otherwise, looking at order operations, let me do the group first. So I'm looking at the inside of the parentheses. Within the parentheses, I'm doing the fraction first. 0.03 divided by 4. That gives me 0.0075. Added to the 1. So I'm going to get that my parentheses is 1.0075. So I just did the parentheses. I'm going to do this to the 20th power. So it gives me like 1.161184 and some numbers. In my result, I'm going to multiply it by 1,000. So my amount at the end should be 1,161 with 18 cents. I run it to 2 decimal places because we're talking about money. Once again, work the parentheses first, or work the fraction. Remember groups, then we do exponents, and lastly, we do multiplication. Now let's take a look at this. Suppose inflation is averaging 3% per year. So the rate is 0.03. To the nearest 100, how many years will it take for prices to double? So let's start with a number. Let's say we start with P, the principal, just to say something. Let's start with $5. Since I want it to double, I want the A to equal to 10 because it's going to double. And my amount of times it gets done here, we're going to say n is equal to 1 because it's done per year. And I don't know my t. But it makes sense that it says how many years will it take. So I don't know my t. So let me replace my values. Instead of A, I'm going to write 10. Instead of P, I'm going to write 5. I'm going to go 1 plus 0.03 over 1. N times t, I know n is 1. T, I'm just going to call it t. N times t, I'm just going to get t, right? 1 times t. Now, in this case, let me get rid of the 5 on the outside. Let me divide both sides by 5 because it's outside of the parentheses. So I'm going to get 2 is equal to 1 plus 0.03 over 1 to the t. But to be honest, whatever amount we started with, I know it's going to double. That's why we have a 2. So it doesn't matter. I chose a 5 to start with. We could have chosen 1,000. We could have chosen $2, $5, whatever we wanted to. Now, I see that the t, the variable, it's an exponent. Let me work the parentheses first. 0.03 divided by 1 plus 1. I have that 2 is equal to 1.03 to the t. I wish I could bring the t to the front, I could bring the exponent, and we can do it as long as we have logs on both sides. So I'm going to say log of 2 is equal to log of 1.03 to the t. And the reason why, because the t comes as a number in the front. I have that log of 2 is equal to t times log of 1.03. For space, let me bring it up here. We're going to get that t is equal to log of 2 divided by log of 1.03. I type this in, log of 2, it gives me 0.301 divided by, I get that 1.03 log, it shows me 0.0128. That's not my answer. That is just telling me how much is log of 1.03. Press equal, and I'm going to get that my t, it shows me 23.449, but I'm running it to the nearest hundredth, so 2 decimal places. I'm going to call this 23.45. Now we're going to say, what if it gets compounded continuously? So my A is the amount we're going to have. P is the principal, how much money we start. E is a number, so I'm going to use the E from the calculator, and then I'm going to use R times T as an exponent. So let's take a look at here. I have the formula there on the right. So we found in example 6 that if we invest $1,000 for 5 years at a 3% interest compounded quarterly, it grows to 1,168. Now, how much would it be if it gets compounded continuously? So let me use this. The principal is 1,000, and I'm going to do E. The rate was 3%, so 0.03. The time is 5 years, so R times T gives me 0.15. That's my exponent. So I do E to the 0.15, that gives me 1.1683 multiplied with 1,000. Remember, I did the E to the exponent first, multiplied to the 1,000, and I get 1,161.83. So if it gets compounded continuously, is this amount. If it gets compounded quarterly, is this other amount. I think it's better to get it when it gets compounded continuously. I'll talk a little bit more in class. Now we're going to do this cases. A is just a numbered and X is just another numbered. Let me do this as an example instead. Use the change of the base to approximate to 4 decimal places. We have the key that says log. The bad thing is that log is base 10, and I have a base that is not 10. So the way I'm going to do this, I'm going to go log of 12 divided by log of 5. If you can type it in your calculator, by all means do so. Just type it in. But in my case, I'm going to go log of 12 divided by log of 15. So I grab my calculator. Log of 12, it gives me about 1.079 divided by 5 log. If you see a 0.6989, that is just what log of 5 is. Don't forget your equal sign. And my answer should be 1.5440. I round it to 2 decimal places. To 4 decimal places. It's just for us to practice.